Hello, everybody. We got another question from 6.1, which deals with arc length. So here, the rotation of a smaller wheel in the figure causes the larger wheel to rotate. Find the radius of the larger wheel in the figure if the smaller wheel rotates 70 degrees when the larger wheel rotates 50 degrees. All right, so let me get my mouse sort of set up so we can sort of take a look here. So again, we want to find this radius. All right, so that's our first hint that we're gonna have to rearrange the formula for arc length. Speaking of which, that formula is S equals R theta, where theta is in radians and R represents the radius. So for the second figure here, the second larger, we'll have to rearrange this so that R is isolated. All right, so it gives us all the information we need to determine the arc length covered on the smaller wheel because we have the radius and they also give us the amount of rotation. Now, with these two angle measurements, we just need to be careful to put those into radians or convert them to radians before using them into or substituting them into the formula for arc length. So let's go ahead and determine the amount of distance along this gear here or this wheel that 70 degrees of rotation will create. So we'll say S sub 1, which is going to correspond to that first wheel. S sub 1 is going to be equal to 12.3 centimeters. We're going to multiply that by 70 times pi over 180. All right, you can put those in parentheses as well in order to calculate this, the arc length for the first one. Now I'm going to bring up a calculator. All right, and we're going to drop those entries into the formula. So I'm going to multiply this by 70. Multiply that 70 times pi over 180. If I can find my pi button, there it is. Boom. Pi over 180. Bam. So it looks like the arc length that's covered along that smaller wheel is going to be 15.027 centimeters in arc length. And I know they say they want us to round to the nearest tenth, but they also say just don't round until the final answer. So I would actually try to capture all of that information that I just calculated to substitute into the second formula. All right, so it tells us that the second wheel rotates 50 degrees, when the first wheel rotates 70 degrees. All right, so what you got to think about is the distance. Say this is the distance, all right? The distance that's covered by that rotation, something like this. It's going to be the same amount of distance. It just doesn't take the same amount of rotation to cover that distance, if you feel what I'm saying. So if you imagine we rotated both of these, we're just going to pretend that both of these ends would stop at the same point after rotating this one this direction and that one that direction. All right, so the arc lengths are going to be equal. All right, so that 15.027 we're going to reuse for the formula for the second wheel that we have there. So we'll call that S sub 2 equals R theta. Similar situation, but this time we're trying to find R. So we need to rearrange this thing. All right, so we rearrange it so R is going to be equal to that sort of second, it's going to be equal to, so that second sort of arc length there divided by the amount of rotation that we have. So we can substitute both of these things in so that we'll even call that R sub 2. So that R sub 2 is going to be equal to that sort of 15.027 and some change divided by, we'll put this whole thing into parenthesis, and it's just going to be the amount of rotation. That's just going to be 50 degrees. We're going to multiply that by pi over 180. All right, and that should convert that to radians, and we're going to reuse that arc length. So take a look at how I do that in with the calculator. This will work on any calculator. You can just reuse that answer. So I'll just go up and hit enter. I want to take all of that, or you can use the answer key. So the answer key is also pretty supreme here, second in answer. That way there's no rounding at all. And then I'm going to use a parenthesis. So that answer divided by 50 times pi over 180, close, and bam. I get the radius of that. Second wheel, and it is exactly actually 17.22 centimeters. All right. So I actually had the problem up here so that we could plug it in, but this is the radius for the second one. Let's just kind of recap what we needed to do here. So just kind of based on the information that we were provided, there are 3 parameters for arc length, and the parameters that we were given for at least the first wheel, we were given the radius as well as the amount of rotation in degrees. So we just went ahead and calculated what that arc length was for the first one, which is going to be the same for the second one. The arc lengths are going to be consistent between the two. So we ended up with 15.027 centimeters in arc length traveled, all right, or covered there. So for the second figure, when we look at the information that we're given, we're not given the radius. We are given the amount of rotation that occurs here with the 50 degrees. And based on our calculation of the arc length of the first one, we've also inherited that arc length for the second. So out of these 3 parameters, the second wheel, or the larger wheel, we know what the arc length is, and we know the amount of rotation, and we're looking to find the radius. So we rearrange this equation so that radius has been isolated, and we reuse that arc length calculation that we had earlier in the numerator, and in the denominator, we take that 50 degrees and we convert it into radians. We divide the arc length by radians, because that's what we have going on, or the amount of rotation, and we end up with 17.22 centimeters. I hope this helps. Feel free to reach out with any additional questions that you have, and I'd love to make a video for you. Take care, and I hope to talk to you soon. Peace.